For binary, for binary ionic, um, remember the word binary means that it's only gonna be made of two elements. Okay, and ionic means that actually you're gonna have a compound that is gonna have a positive ion or cation and a negative ion or an anion. So, first of all, we have an example that says aluminum sulfide. Just because of the ending, just because of the suffix IDE, I identify that this is a binary compound. And by taking a look of the aluminum is a metal. So, knowing that I have a metal in my compound, I know that it's going to be ionic compound. So the way to write the formula is first the cation and then the anion. Aluminum is a cation that is written as Al and has a charge of 3 positive. Sulfide refers to the element sulfur, okay? It refers to the element sulfur. So the anion for this compound is going to be sulfur. And remember that sulfur uses a charge of -2. Now what we do after is we need to crisscross the charges that are different than 1. So this 3 from aluminum comes to sulfur, and the 2 from sulfur comes to aluminum. So in the end, the chemical compound formed is Al2S3. And this is a compound that we know as aluminum sulfide. In this example, we don't use Roman numerals because aluminum has only one charge. But let's take a look to the second example. The second example is Cu2O. Okay? So the first thing that you need to notice is the element copper. What kind of element is copper? What kind of element is copper?
A transition metal.
It is a transition metal. Okay? So that's the first analysis that you have to say. Copper is a transition metal. Okay? So there are two possibilities for copper. There is a possibility for copper 1 plus, and there is another possibility for copper 2 plus. Okay? So to know which one is the one that is in the formula, I could try by mixing the two coppers. Okay? So I'm gonna try forming two different compounds with the copper, with the two different coppers. Xavier, Kenneth, Angie, please turn the cameras on. So you could have copper with a charge of 1, or you can either have copper with a charge of 2. So you can combine the two coppers in the end. Okay? So if you have copper 1, what you're gonna have in the end is copper combined with oxygen. Oxygen, remember, that is 2 negative. And in the other side, you could have copper, but now with a charge of 2, combined with oxygen, which has a charge of -2. So we crisscross the charges that are different than one, and in the other side, you know that you have the same charge but different symbols, so they're gonna be cancelled. So, what compound corresponds to the exercise? Compound A or compound B?
A.
A. A is exactly the compound that it was given in the problem. So, the charge that copper used in this exercise was the charge of 1. So, the name for this compound is going to be copper. You need to specify the charge, the right charge, copper 1. Remember, this one, even if we did it, we're not going to use it since it's not the same compound that it was given. Okay? So the name will be copper 1, and then the name of the anion. For oxygen, the anion is known as oxide. So finally, the name will be copper 1 oxide. Kimberly, your camera must be on. Now, right now, you as a classwork, you're gonna work in the exercise A and B. Okay? You're gonna write this formula and you're gonna write the name of this compound. Did you finish? Did you guys finish? Okay. So the other binary topic that I have here is binary covalent. Okay? Binary covalent. This is the other topic that we also know as the prefix system. The idea of this topic is that you replace the number of atoms by a prefix from the table of prefixes that I already gave you. For example, the first example here, it has 4, and 4 is known as beta. It has also 10, and 10 is known as deca. Okay? So right now I'm just going to write the formula, I'm sorry, the name for this compound. This compound is made of 4 phosphorus and 10 oxygens, okay? That's the idea, okay? That's the number of atoms, that is what it represents. So, because it is made of 4 phosphorus, the name is going to be tetra. Instead of the 4 is tetra. And then the name of the element, that is phosphorus. And then for 10, okay, the prefix is deca, and then the name of the anion, that is oxide. But remember, there is a rule that says that when the if the last letter from the prefix and the first letter from the anion begin with open vowels like A and O, you need to drop the A. So in the end, the name of this compound will just be tetraphosphorus decoxide, not decaoxide, decoxide. Tetraphosphorus decoxide will be the final name for that compound. Now, if I give you the name and you need to form the compound, take a look. If the first element is alone, if the first element is alone, means that the number of atoms is going to be just one. Okay? And now take a look to this prefix. This prefix is tri. Tri refers to number 3. That means that this element will have 3 as a subscript. What element is this? Take a look. It says sulfide. Sulfide refers to the element sulfur.
Sulfur.
Okay? So, from this, we have all the information now to write the formula. So, chlorine comes first, okay, with 1 as a subscript, and then sulfur comes after with 3 as a subscript. But remember that 1 as a subscript can be totally ignored because it is invisible. And this will be the formula for chlorine trisulfide. Now, during your notebook, work in these two exercises. You finish? Okay. Now let's see the rest. Wait a second. I'm giving you more time to work. Okay, I was checking that someone left, so I was trying to write it down. Okay, um, the next two exercises are for ionic polyatomic. For me, in my opinion, this is the easiest way. Why? Because the naming process depends only on the name of the polyatomic ion. Take a look here. Take a look this naming process. It says barium, and here I have barium. And it says phosphite, and here I have the ion phosphite. So the naming process is the easiest of all the kind of examples because you have to write the name of the cation and the name of the polyatomic ion. Just be careful on the polyatomic ion that is given to you, because if for some reason I change this number like that, then my name is also going to change. It won't be phosphite anymore, it will be phosphate. You see? One tiny number affects your final answer. So be careful on that. Now, for the second example, I have gold 3 sulfate. So this 3 right here is telling me that gold is a transition metal that has multiple charges, but the charge that is using in this compound is the charge of 3. Okay, that is what the number 3 in Roman numerals is telling me. So I'm going to write the symbol for gold, which is AU, and I'm going to write the charge that is specified in the problem. The charge is specified as 3. Okay? So my compound is going to be formed of gold 3. And then it says sulfate. Sulfate is a polyatomic ion. What is the formula for sulfate?
It is SO, the charge is -2, and the subscript 4.
Exactly. Sulfate is SO4 and the charge is -2. So you're going to combine the two of them. And because the charges are above, I'm going to crisscross the charges like this and like that. So in the end, this is going to be AU2O4, sorry, SO4, and then the 3 from gold, okay, the 3 that is coming from gold. And here, since I cannot have these two numbers together, I need to separate with a parenthesis. And now it's well written. Remember to crisscross the charges, always. Only when the charge is just 1, you're not going to change it, okay? But in the case that you have multiple charges, you have to specify in Roman numerals. Also, sometimes remember that the charges are going to be cancelled, just like we did in this example here, okay? Here we cancel the charges because they were the same number, but with different symbol. So right now you, in your notebook, work with these two exercises. Did you finish? You finish? Okay, okay. Aria, Aria. Oh, okay. For this last part of the topic, we have the acids. Okay. Remember that acids are classified in two. We have binary acids. There are those acids that are made of only two elements, and we have the oxyacids or oxoacids. It means the same, are acids that contain oxygen. So this first part, I will be in this first part, I'm gonna be with you with examples for both binary and oxyacids. Now, remember the mnemonics that I shared with you the other day from the video from this Tyler DeWitt. Okay, remember this. When the anion when the anion ends in IDE, the name of the acid will include the prefix hydro and the suffix -ic. So let's follow these mnemonics for this exercise. I know my cat is crazy. So HF. The F tells me the name of the anion. The anion is fluoride anion from the element fluorine. So, because it ends in IDE, remember the mnemonics. I. My ride has hydraulics. So the name of this compound will be hydro, and then the word acid. And what I'm going to write between hydro and it is the root of the anion. The root of fluoride is the fluor. So the name of this acid will be hydrofluoric acid. My ride has hydraulics. Now, what if I give you the name? Take a look at the second example. It says hydroiodic acid. What element, what anion I'm talking about? Remember, I have hydro and I have it. So I'm going to get the root that is in between to find what is going to be my second element of my binary acid. Iod. Iod. What element is iod?
Iodine.
Iodine is the element and the anion is iodide. Iodide. Iodide is just I with a charge of -1 and iodine is the iodine element. Okay, it's different. But in the end, it doesn't matter. Okay, all I want you to know is what element are we talking about. So, in the end, the formula for this acid is going to be hydrogen because it's an acid and the iodine, the I from iodine. So hydroiodic acid is just Hi. Now take a look to this one. I'm gonna write one more example here. Okay, so now that the first two were the binary, okay, because they had the hydroic, okay, but the rest of the three are oxyacids because they have oxygen. I have oxygen here, and this one do not include the prefix hydro, so I know they are oxyacids. So the rule for oxyacids is the mnemonics number 2 and 3. Okay? Those that say, I ate something icky or Sprite is delicious. In other words, if my anion ends in ate, ate is going to be replaced by ate. For example, the first one. We have the ion chlorate. So it ends in ate. Chlorate ends in ate. So ate will be replaced by ick. Remember, I ate something icky. So in the end, the name of this acid is going to be chloric, chloric, and then the word acid. Chloric. Instead of chlorate, chloric. Now, the second example, I take a look of the suffix. It says phosphoric. Okay? So, if it ends in ick, if it's icky is something that you ate, okay? Icky is something that you ate. So phosphoric acid refers to the polyatomic ion that ends in A. In this case, it's going to be phosphate. Phosphate. Remember that phosphorus has a special root. And because it's phosphate, you write the ion over there. And because it's acid, you write the H. Crisscross the charge, and the final compound will be H3PO4.